Okay, so for this office hour, we are talking about GitHub and Git and how version control sort of works. Now, one thing that is important to think through when we're dealing with version control and just honestly development is understanding how to navigate your computer, right? And understanding when you're using the terminal, how it's working. I'm not sharing my screen, am I? Absolutely not. How funny. Okay. Now you guys should be able to see it. Sorry about that. But how the terminal works, right? And what it's doing, where we're at in our computer. The reason that this is important. Yes, there are tools that we can just go on VS Code, download GitHub. There's extensions, and then it just does it for us. But when we are dealing with the cloud, when we're dealing with a lot of things, what's actually happening is like if we are going to the cloud, right? What I can do is I can, what's happening is I've got my computer here, right? That's got all my code on it. That's your local machine, your local host, right? It's got all your code. It's got your entire project, your database, all that stuff. But when you want it to go to the cloud so that way other people can view it, right? You have to go into the cloud and there's various ways, there's SSHing, but there's a way that we have to put our code from one place to another, right? We have this little computer in the cloud, we call it server. And we need to take this code right here and we need to transfer it to the cloud, right? To this computer. So that way this has all of our code. So that way we can, that way this machine can run our application or run our website and then people can visit it, right? If it's just on our machine, then they can't visit it unless our machine becomes a server, but that's a whole other thing. The reason it's important to understand the terminal is the process of us logging in, remote accessing in to a server often is something where you're using Ubuntu or using some sort of process or some sort of tool to log in and navigate that computer. Now that computer doesn't have a screen that we can visualize. Does anybody remember what the visualizing tools are called? It's a 3-letter word. But if I have a visualizing tool that does something, what's that called? Does anybody know? It's called a GUI, right? A graphical user interface. And so any sort of thing that you click a bunch of buttons and something's happening on the background, that's just a GUI, right? That's just a visual representation of what's going on under the hood. And it's oftentimes easier for users to use, right? It doesn't make sense for users to input forms in a weird way. They just click a bunch of buttons and it's a graphical user interface, something the user uses. And then in the background, it does some sort of, algorithm or it does some sort of functionality. Now, when we're dealing with the cloud, when we're dealing with putting things on the cloud, oftentimes we don't have that visualization. We don't have a GUI. We don't have anything like that. So we have to interact with our computer or interact with the other computer and navigate that computer just based off of our terminal, whether you're using ZSH, if you're on Windows or sorry, Mac or Linux, you can use ZSH, or if you're on Windows, you use command prompt, PowerShell, Git Bash. There's a bunch of different ones. But navigating the terminal and being able to do that is an important tool because, again, you're not always going to have a visualization. The way to sort of think about it is if I've got a bunch of folders on my desktop, that's something I can click on. I can click into that, and then it goes into another folder, and I click into that, it goes into another folder. That's a visualization of what's going on. I can accomplish the same thing by just using my terminal and navigating. Cool. So here, I am in this folder called Lecture 2. Now, there's a couple of different things when we're dealing with Git that we can, we'll talk about, right? Can anybody tell me what is Git? Is Git the same thing as GitHub? What do you guys think?
I think it's different, right? It uses Git, but Git is kind of what is the process that saves it, right? Or something like that.
Yeah.
I think Git is like a terminal and GitHub is like a central repo, like a github.com, central repository. or source control.
Yeah. So I see Jennifer put this in the chat as well. Git is what we call version control. It is, you think about it, if you're using, so like Microsoft Word, or if you're using Google Docs or whatever, when you press the save button, you're saving that file. If you're on your actual computer, you're saving it to the computer. A repository is kind of the same way, where it's saving the information, the code that you have, and it's a way that we can store and save it. And as we keep iterating, as we add more code, we save and update it, but we have all of our different versions, right? And so what Git's power is we have, and it keeps kind of a snapshot of your code. Every time you commit, that's us saving it, we're committing our code. Every time we commit that to a repository, it's a way that we can, it's just a snapshot of our code at that point, right? And the good part about that is, let's say that I commit my code works, my project works, that's great. And then I go and I continue to work on my project and I just muck it up, right? I muck, M-U-C-K there. But I just totally ruin it and it's all broken and I can't figure it out. Well, the good part about Git is, remember, it keeps those snapshots of my last commit. I could always just revert back and kind of start new, forget what I just did. It's kind of the Command Z, and I can kind of go back to that version when it did work, and then I can restart or do something of that nature. Cool. So what's happening under the hood? Well, you can sort of think about, and this is going to be a little bit more theory, and then we'll get into actually using it, is when we create a repository, we are creating a snapshot on our computer using Git. We're creating a snapshot for our code, right? You sort of think about this as the lifespan of my project. We are just creating a snapshot, right? At the very first initialization, can anybody tell me what the command for initializing a repository is? Anybody know it?
Git init.
Yeah, git init, right? So git, G-I-T, init. That is initializing a repository. It's saying, hey, I want you to keep track of this specific repository, this code base, right? Now, one thing to note is you don't want to have, and this is for all of my JavaScript friends, this is what happens often, is you don't want to have, or don't want to initialize a repository inside of another repository. I believe Vite, I can't remember if it's Vite or Create React App. One of them already creates initializes a repository for you. And so you'll get an error that says, hey, it's inside of another repository. So you just want to back out and then figure that out. And we'll look at how we can do that and what can we do to try to figure out where that repository is here in a second. But when we initialize, it's just this sort of beginning snapshot of what's going on. And in fact, I would say that this hasn't even happened yet. We have just initialized our code. Then we say, okay, I want you to create a repository, but then we say, what do we want to add to the repository? Okay, I've created this thing. It's kind of just like a placeholder. Like if we're dealing with JavaScript, we have two different options, right? I can say like let x equal 3, or I could just say let y, right? Both of these are variables. This one is actually giving a value upon assignment, right? I am assigning this value to this variable that's being created. This other one is saying, hey, I want you to create a variable, but I don't have a value yet, right? I don't know what it's going to be. It could be a string, it could be anything, but just hold that I have a variable called y. That this is our git init. Then once we have our code, or as we have our code, or maybe the next step is we want to add in the actual code and say, this is what I want you to remember. This is what I want you to save, right? This would be like if the next line, I say y equals 5, right? This is how we add a value to our variable in this case, but when we are dealing with git add, that is actually adding the value, right? So my command is git add. Now with git add, and we're going to do all of these, this is just theory. We say, what do we want to add? You could either give a file name if you just specifically wanted to add just the index.html, or you just wanted to add something else, or you could do space period. And that's going to be, I want you to add everything within that folder, add it. This is us giving value to our repository. This is the code that we want. Now, though that's happened and it says, okay, this is us adding the code, you can sort of think about when we're dealing with a Microsoft Word document or something. This is us pasting our code and it has it all there, but we haven't pressed that save button yet, right? So we said, okay, great. Let's initialize this. I'm adding it. I'm pressing, let's say I copied it from somewhere and I'm pasting it here. Now I want to save my code. And that's officially means that, okay, great. I am keeping track of this. This is a snapshot of, this save is a snapshot of my repository at this exact moment. And to do that, I say git commit. Cool. These are your big three for dealing with your repository. Your git init, your git add and whatever you want to add, and then your git commit, right? These are your big three for your Git repository. This is on your computer. Now, one thing to note is when we run git init, wherever we're at in our terminal, it creates a hidden folder called .git. Now for Mac and Linux, if you type ls space -a, that's going to get you all files within that folder, including the hidden ones. And so then you'll see this .git, and we'll visualize that here in a second. I believe that's the same thing on Windows, but yeah, all of these have a space. So git is your keyword that tells, hey, I want Git to do something within my terminal, and then it's space init for initialize, or git add. And then again, what do I want to add? I can either add a file name or I can just press period or put a period there. And these are all spaces in between. And then that gets everything. And then I say git commit. This one's going to be a little bit different. And then I put -m and then some message. And some message is just placeholder, because this is when we are making a commitment. It's just with our snapshot, it's kind of saying, well, what did I do? Right? I added color to, an image, or I worked on CSS becoming dynamic, right? It's just a message to say, hey, for this commit, this is kind of what it's about. You don't have to like write a paragraph, but you could just be like updated user page, something like that. So that way, when you're going through all your commits, you could be like, oh, that's the one. When I was updating the user page, the thing on the user page is broken. So that might be the commit. I can go back to there, something like that. So those are your big three. And again, these are just for Git on your computer. The version control on your computer, you have to have that downloaded. You should already have that downloaded. That's in Web Fundamentals. But this is just the version control on your computer. Now, there's something called GitHub, right? GitHub is the most popular version control online repository tool. It's owned by Microsoft. Fun fact, they own like everything in the coding sphere at the moment, but it's owned by Microsoft. And it's a way that we can actually just save our repositories onto the computer or onto the cloud, kind of. So that way other people can interact with it. This is whether we're doing open source, whether we're working with a team, whether you're working for your company, or just you're creating a profile of here's all my code that I have, right? You're just contributing code, and it's just a way. What's nice about it is, and this is a reason why we have GitHub, is Git exists on your machine, right? On your machine. Oops. The power behind GitHub is, let's say that your laptop gets stolen, right? Well, if you just have everything saved on just your computer, you're kind of SOL, right? All your code is there. All of your projects are there. If you didn't save them anywhere, it's not it's not, you can't really get it back, right? Or you can't get it back unless you get that actual physical computer back, because Git is just on that computer. What's nice about GitHub is when we push things to GitHub, let's say your computer breaks, or again, your computer gets stolen. you could always go and clone or grab those repositories back from GitHub and get it onto your local computer. And so it's kind of like a backup. It's putting something in the cloud in the same way we save things as you know, in Google Drive, or we save them in SharePoint for Microsoft. So that way, any computer or any friend, anywhere in the world I am, if I don't have my computer, I can go and I can get my code, or I can get actual repositories. I can clone them, bring them down from the cloud back onto whatever machine I'm using, and I can work on them from there. Say that your company, you know, your computer gets hacked or something like that, they send you a new computer, you're good to go because your code is saved up in the cloud and not just on your computer. That's like the worst thing you can do. GitHub is not the only one. It is by far the biggest, but like Gitbucket's another one. Code Commit from AWS is another one. Depends on what company you use. They might have different repository systems. They're all basically the same in the sense of they're just all online repositories that you can just push your code to. And what I say push, that means take it from your local machine and push it to the cloud. But that's sort of a later step, right? That when we're actually finally connecting, we push them together. Cool. Any questions on this stuff at the moment? Does this make sense? How's this feeling?
I have a question. So,
Yeah, go ahead.
Git, like I guess, so Git would just be on your machine, right? Is this doing this already? Or, like when we're making files in VS Code, is it doing that for us? Or is Git
Nope.
something that we have to do it, and that would be to store like screenshots as far as where our code is in time. And we
Yeah,
would commit it
saving
to
your
Git.
code. Yeah.
Okay, and then that
Like
would
it's
just be
saved.
your file explorer?
So that's a great question. When you have code on your computer, you're having it in some folder and you're saving it that way, right? This is a different version control to where it's saving it in what we call a repository. And it's a different type of way that we save code. And again, the difference is that with our folders, let's say I have my project folder, if I go and I mess up all my code, well, that folder just has whatever code I most recently did or most recently saved, right? Which is the
Mhm.
autosave, so it kind of messes it up. What Git allows me to do is backtrack back through. And so it's a different type of saving. So it's not just saving it as a file, it's saving it what we call a repository on your computer. But yes, it is local just to your computer alone.
Okay.
Does that make
And then,
sense?
yeah, 100%. So how would you go grab that? Like
What do
you would have to be in your terminal, then you would do
you?
if you
Yeah,
did
I'll
a
show you. I'll show you exactly. We're gonna walk through exactly. We're gonna
Oh.
put something on GitHub for sure.
Okay, cool.
Yeah. Yeah. So I see Austin said, where can we find repositories on our local computer? If you've saved things, I'll show you how to find it. And then if you haven't saved it, you know, you can, you know, you'll know pretty quickly that you haven't saved something because it's not there, right? And so that means you haven't initialized repository. Cool. Now, the last thing I want to add on is another tool, and I know that I said that you guys could, you know, if you finish your project, go ahead and just make a copy of it and then kind of deal with that. Another thing that we do, and this is where really the group projects are going to come in handy, is, and this, I think this is going to have to be a two-parter, just honestly, we'll do kind of group project stuff, but I just want to bring this up, is instead of just saving the folder on your computer, has anybody seen the show? And I think I was with Crystal today. We were talking about this. Has anybody seen the show Loki? Like the Disney Plus show of Loki?
Season 1, yeah.
Yeah, exactly. So if you remember, if you haven't, it's just about like timelines and stuff. And there's this timeline, and then there's these like little branches off of the timeline. These are like I don't know, multiverse, or I don't quite understand it, right? And these all different branches. It's a copy of this timeline. But then, you know, other things happen that wouldn't normally happen. Or if you've seen Umbrella Academy, the last season's awful, but same sort of ideology, right? Is there's these different timelines where different things are happening. Within GitHub, or sorry, let me backtrack. Within Git or any repository, you can use it on GitHub or whatever. We have what we call a branch, where instead of just making a copy of your entire project and then having, you know, two versions you don't really know, you can have your repository. Let's pretend that this is your code. And then at this moment, let's say that you want to, or it's your project's done, right? You've already saved it. It is done. And you're like, okay, great. I want to make sure that I don't mess this up, but I want to keep working on this project. I want to try to implement something. I want to try to implement something harder. We can create what we call a branch. And the way we do that is we can check out a branch. And what a branch is it's a copy at that point in time. Whenever you check out the branch, you make the branch, it's a copy of your entire repository. You can sort of think about it like option B. So it's an exact replica, but you can mess with it and update your code. What's nice about it is, let's say that you just can't figure it out. Well, the original copy or the original repository that we call main, the main repository isn't affected, right? You're just, anything you're kind of working on is on this copy, this copied version. So your actual repository, the kind of, master file, it used to be called master, but now it's called main. That is not affected, right? It doesn't have your changes. So it's kind of in a way, instead of just having to make a copy, actually copying the folder, you could just make a branch and you can try to update your code. Now let's say that, okay, great. You've presented at this point, you're good to go. And then you have this branch and you say, well, actually, I figured it out, right? I want my code to be able to go onto this main branch, right? I want to kind of close out this copy and I want to morph it into the main branch. Well, that's what we call a merge, right? And so there's a couple things that happen, and this is going to be a big deal when we're dealing with groups, is you can sort of think about at this time, think about this as like a timeline, right? Where, this is like day 1 and this is like day 10. Well, say day 11, you're like, I'm ready to merge my code and I want it to become, I want this main portion to have all this new code that I added because I added this wicked cool feature, right? Well, something that happens is we just need to merge the branches together, right? And so if I have this as main, it's my main branch, and then maybe I check out and create a new branch called X. Well, I just need to merge main and X together. Now, here's where the tricky part comes. For just you, just dealing with this, it's not going to be a big deal. As long as you didn't continue working on the main branch while also working on the X branch, you're going to be fine. It's going to merge and it's going to be A-okay. Now, where the issue comes is when we're dealing with groups, and the whole reason we do a group project is literally to handle this. Because let's say that hypothetically, at this point right here, let me backtrack. At this point, where we made our branch, let's say that Daniel makes a branch because he's going to work on something on the front end, right? So let's say that this is branch Daniel. A couple days pass, and let's say that Edwin is in a group with Daniel and wants to update something on the back end. So a couple days pass. Now Edwin makes a copy because he checks out a new branch and is now working on something on the back end. We're going to call this branch Edwin. Now we still have our main branch, right? And a couple days go by, still have our main branch, but let's say that Edwin just had to do a quick fix and is ready to merge and say, okay, now I want my new code to be on the main branch and I want that to be kind of the new main, right? Well, what Edwin could do at this point is go and merge his code. And so now the main branch has Edwin's code. Cool. That makes sense. That's something we just saw. Now, a couple more days passed. Daniel had a really hard job. And Daniel goes, okay, great. I'm now ready to merge my code with the main. Now, this is where, again, the biggest issue for students in groups, this is your biggest thing, is Daniel took a snapshot of the main branch at this point right here, right? and has been working with that snapshot or that version of the repository this entire time, right? Well, when he goes to merge, the snapshot code that he has, or the thing that's representing the main repository, no longer matches what our main repository is. Why is that? Anybody know?
Because they merged previously.
It was
Yeah, because now
Change.
this main branch not only has the original code, but it has Edwin's code with it, right? And so what happens here is Daniel's trying to merge his code, which has the original copy, with a newly updated main branch. And so this is where merge conflicts come in. This is the biggest issue. So how do we handle that? Well, what Daniel will do before he tries to merge his branch with the main is he goes, and if there's good communication with the group, he would know that Edwin's part is done. And he says, okay, well, great. Before I do this, let me kind of delete this part. Before I merge my code, cool, my code's done. Before I do that, let me make what we call a pull request. I just want to see, again, if there's good communication. He goes, I know the code's not the same, so I want to do a pull request. This point right here, right? What a pull request does is it says, hey, does what I had at this snapshot match what is currently my main branch? Do these match? Are they the same? If they are, then that's great. There's nothing that needs to change. I'm going to merge these two together. At this point, he would say, well, no, these don't match. And Git would be like, no, you actually have conflictions. You have a merge conflict. If you were to try to merge, then you have a merge conflict. But right now, I'd say, no, there's actually been some updates, right? Some insertions or deletions. Either Edwin maybe deleted some old code and updated the new code, something of the sort, right? And so Daniel would go through the code and accept any sort of changes, right? And says, okay, great. Yep, this makes sense. This makes sense. This makes sense. Also would check and make sure that none of the issues or the new code, sorry, not the issues, but none of the new code that Edwin did is going to affect what he just did, right? He's going to make sure and test it and run it and say, okay, great. Does mine still work? If at this point, it goes, okay, great. It still works. I've updated what my snapshot of the code is because I did a pull request. I've accepted everything. Great. I now have an updated version when I'm comparing my main. I now have that updated version. Now I can merge to main. And then now, once he merges to main, main's going to have Edwin's stuff still, but now it's also going to have Daniel's. And so now the new main is all of the code that Edwin and Daniel had. The pull request is what students oftentimes forget. So they just try to merge. When they try to merge, there's conflicts because your original snapshot does not match what it takes a kind of you can think about it like it takes a snapshot that you had and it compares it to a snapshot of the current repository and it says, are these the same? When they're not the same, that's when you're going to get a conflict. So you always do a pull request, and we'll as we get into next week, we'll kind of test that, and I'll show you how to do a pull request. Always do a pull request to make sure, cool, do I have enough? Do I have the code that I need in order to make a merge? Does that make sense? Cool. Okay. So let's actually go and make a GitHub repository. Let's make a Git repository, and then we will put that on GitHub. So what I have here is I'm in my terminal. I've already navigated, right? Here is my present working directory. I start out in William Calhoun. I navigated to my desktop, to Coding Dojo, to instruction, to OGP&A, week 2, lecture 2, right? That's where I currently am. And this is what I want to put on GitHub. Actually, let's go back even one, cd space ... Remember that goes back one. Now I'm in week 2. We'll just do OGP&A. That's great. Cool. Now here, I can type ls. ls says, give me a list of everything that's currently available to me. But I said I wanted to check and did I, or, you know, I can't remember. I have a bad memory. My wife will tell you that for a fact. Let's pretend I don't remember if I created a repository or not. I can type ls space -a. And that's going to give me all of my hidden files. If I had one, I would see a .git file here, but this tells me I don't have a Git repository within this. So that's great. I can initialize one. So I say git init, and you have to download Git. I'm assuming Git is already downloaded. This again should have been in the web fundamentals section. There's a whole Git portion. And so I'm assuming that Git's already downloaded. If not, you do need to download Git. Say git init. Cool. Initialize an empty repository, Git repository, and then it tells you, hey, within ogpna, there's a folder called .git. Now, if I type ls, you don't see it. If I type ls space -a, now we see a .git. This is my repository here. Here's my snapshot of this folder. Cool. I'm going to pause there in case anybody's trying to follow along.
Can you just explain that again one more time from the git
Yeah.
init, like right before you did the git init, and then say it one more
Uh-huh.
time?
Yeah, so what this is doing is my ls is just saying what is currently in this folder, right? This is what I want to put on GitHub. I want to make sure that there's not already a repository there. Well, ls only shows me what my visible files are, my visible folders, files and or folders or whatever's in there, you know, images, whatever. If I type ls dash or space -a, that gives me all files within that folder, including my hidden ones. Now we didn't see a .git here, so I know, okay, great. I don't have a repository currently linked to this folder, right? And so I can say git init, and this initializes a repository. It says, hey, I don't have one, so let's go ahead and make one. So I say git init, and it says initialize an empty Git repository. It's the same way as when I say let y or let y. It's creating something empty. It's keeping track of it. It just doesn't have anything in there, right? And so it's initialized this empty repository, and it tells me where it initialized it at. I'm in my ogpna. That's where my current present working directory is. And so it's saying within there, I created this folder called .git. Now, if I were to look at it though, I don't see it, right? It's not a visible folder. It is a hidden file, a hidden folder. So when I say ls-a space -a, that gives me all folders, both hidden and visible. And now I see, okay, cool. I do have a repository there. Great. So it's just kind of confirming, yep, I have a repository here. Does that make sense? Yeah, of course. Okay. So like I said, this just initializes something empty, right? Let's do this. Let's give it some value. Well, I just want to throw everything we have at it. Haptamu, go ahead.
I have this problem, like when we do Java, JavaScript, or Python stack, I create a folder for that specific stack, and then I had this Git repo, and then in that folder, I create another folder, and then download or git clone another repo. Like I have multiple repo in the same folder.
Yeah, you
When
have a nested repository.
Yeah, and then it shows me like thousands of untracked Git files. So when I try to like Git commit, says like it's different repo.
Yeah.
It is
Yeah, so you
it's-
can't have a repository within a repository.
right. So I missed
So how do we deal with that? Let's
Yeah.
pretend I say, great, now I now see I've got an empty repository, or I've got a repository within a repository, right? Because my week one is inside of ogpna. Ogpna is .git. If I were to say ls-a, I have this in here too. Uh-oh, that's not ideal. So what we can do is go to our parent, whatever you want, and say, okay, great. Our parent has this Git repository. What I can then do is navigate to whatever folder that has the issue. I mean, in this case, it's week 1, and I say rm-rf.git. This is going to remove, and then it's remove force, the Git folder. So if I say ls-a, now you see it's gone. So I'm getting rid of that repository because it's nested. You can't have a nested repository. And so now I'm working within the parent. So what you could either do is get rid of the parent if you wanted each individual one, which I would actually encourage, because, and we'll look at GitHub in a second, but it's however many repositories you add, it gives you like a, this is how active you were. It's stupid, but then people will look at it. Like recruiters will look at it. So I say put every project as something new. But if you wanted to have a parent one, you can. Either one, you just go and you remove whatever repository that you don't want by using rm-rf.git. That is on Windows and Linux, or sorry, Mac and Linux. You could just type in what is that for Windows, and it'll tell you. I think it's
So-
Dell or
Okay.
something of that nature.
So you're saying like just remove the git.git file from the nested, from the parent repo, so
If
that,
that's, yeah.
and then so the nested repo will move to the upper level and be visible, not inside the parent repo, right?
So if you've got it in your project, like in this case, let's say that week 1 was a project, right? And it's within my parent of OGPNA. Let's say I didn't want, it's totally up to you. Do you want it all in one? Do you want to have just a repository that has all your Java stuff? That's fine. You could do that. You could still interact. So either one works. There's not really like you don't have to do one or the other. But you decide, where do you want this at? If you want to have it in just your OGPNA and now everything I do, I just push it to GitHub. We'll see how easy that is. That's great. If you want practice in every single project, you want it to be its own individual repository, that's also fine. If you wanted each one to have their own individual repository, you would navigate to the parent, you would run the removal of this Git repository, and now you don't have a nested one, right? Because the parent is gone.
Okay.
So if you just wanted the parent, navigate to every project you have and remove those Git files, and now you don't have nested. So either way, we're just getting rid of the nested, however you want to handle it.
Okay, thank you.
Yeah, of course.
So like, Will, for example, when we made the React apps, we had a client folder and a server folder. So you would want the Git encompassing both of those, right? Because then if
Yes.
somebody switches the client side, then it would just be a branch, right?
So you would want the Git. So this is an interesting concept. And this, I don't want to get too far off there. I would say for you guys, you want your actual application folder to be your Git. It encompasses your client and your server. Now at companies, it is not uncommon to have each one as their own individual repository, because at a bigger company, you're going to have a front end team, and then you'll have a back end team. And so those two teams are different, right? The products, or maybe you're building an API, and then another team is building a visual, like a dashboard or whatever, and they're calling the API, but they are two separate products. And so it's whatever you really need. For what you guys are doing, I would say you're not really building like a robust API every time or robust front end every time. Just keep it as your project, because that's really telling the story to people that are looking through your code. They're saying, okay, this client with this server, it's this project, right? You're not building some generic API. But I just wanted to say that because it is not uncommon for a team to have a front end and a back end team, or a company to have a front end back end team where they are just different. But for you guys, yeah, it's the parent folder that has both the client and the server. That's where the Git file goes.
Okay, gotcha. Thanks.
Yeah, great question. Okay, so let's navigate back to, Okie doke. So let's navigate back. This is where we have our folder. And again, remember, I just created an empty variable. That's all I've done. I don't have any value associated with it. So let's give it some value. Now, the way I do that is I say git space, add space. And now I can, if I just wanted to, let's say I didn't want anything with week 1, I could just say week 2. And it will just add week 2 to this repository. Great. I could say week 2 / lecture 1, and it's going to just go into here, and it's going to get me just the lecture, that specific folder. I can be as specific as I want. I could go in that and get just a specific file as well. For what you guys are doing, you really just need to put a space dot. This is going to say, get me everything within this folder. I want it all, right? Git add space dot. Cool. Now you're going to look and you're going to say, well, doesn't look like anything happened. This is where, especially when you are just getting started, you can run another one called git status. And you could see that, hey, on my main branch of my repository, I have added all of these new files, right? When they're green, that means that they are an added thing. If I were to go in and delete, and I were to add everything, it would say, hey, I've deleted a file. And so it'd be in red. But these are changes to be committed, right? I have basically, remember back to the analogy, I have pasted and said, hey, great, here's everything I want. And now I just need to press the save button. I just need to press the save button. So the way we do that is I say git commit -m. This is, I'm going to make a commit and I'm going to write a message with it. And then I'm going to say added PNA code. You could say first init or first, first init or first repo or, updated color to pink for, whatever, made a unicorn theme. Describe however you want it. Doesn't matter. Unicorn cupcakes, doesn't matter what you say. It's just a note and we'll see the note, but it's just a note of what you did on that commit. And then I press this. And it says, okay, great. I have inserted, there's 358 insertions, but I've changed 15 files and I've created them. So now this is my repository has updated my code. I've committed it and it says, great, here's a snapshot. Here's my snapshot of my current main branch. Cool. So how do we get that on GitHub, right? This is done on my repository side, but now we have to get our GitHub up and running. So when you go onto GitHub, it's going to say something like this, right? You're going to have something like this, gross, but you're going to have repositories. You're going to have people you follow. GitHub is a tool in a sense. You can have your own profile. Mine's trash. So, if you want to really dive into it, you can. But here's my profile. Here's some things that I did when I taught for Microsoft or when I, did certain things with data science, right? Here's all these like customized things. And this is what I was talking about for contributions, or why I was saying maybe each project needs to be its own repository. Now, it's not very indicative of how much you code, because, most companies don't just allow you to post to GitHub, right? Or sorry, they might do GitHub, but they might do something else like code commit, right? My old company was just, everything was on code commit. So I coded a lot, or even here at Coding Dojo, I don't push our code to GitHub anymore. We don't do that. And so you can see that I very rarely have anything pushed here, but I code all the time, right? And so, but for you guys, again, it is a dumb thing, but recruiters will look at this and say, hey, how much are they actually coding, right? And you can see like less and more, and it kind of gives you an indication of, oh, there was 1 contribution or 3 contributions. You guys have this whole bunch, especially if you took 3 languages, you have a whole bunch of projects that you can add to GitHub. I would space those out. Do 2 or 3 a day. Add them in, and then you're going to start getting a bunch of different colors, right? To where it'll say, oh, they code a lot. Again, it's not indicative of how much you're coding because you've already written the code. It's just there and you need to put it on GitHub. But I would space it out and not put every project on one day because it, if you've got a bunch of stuff, you can't put core assignments. But if you've got other things that you've been working on, then you can add it to GitHub, or if you do optional stuff, then you can just add it to GitHub here And then now you know, it kind of looks like you're coding a lot. Jennifer, I see you got a question?
Yeah, I was just wondering if you had any thoughts about like some of the earlier stuff that we put on GitHub, if, at some point would we want to go back and delete that because, our skills have leveled up by that point, or is it better to kind of preserve the history that you were working all that time?
Yeah, great question. I've heard it both ways. I've heard from recruiters that it actually shows how much you've progressed if you can look at your code and then where you're at now. So I've heard an argument for keeping it, and then yeah, it's just history for how long you've been here. So I wouldn't delete it personally. There's not really a need for that, especially if you're working on new things or you're working on personal projects. I would just keep it there, because at this point of your careers, just an abundance of code is better than just having, one or two better coded things.
That makes sense. Thank you.
Yeah, of course. Because it'll look like you'll have like, oh, he has 114 repositories. Cool. Versus like 2, right? But those 2 might be way higher quality, but still might help there. But again, this is something that you can use. You can edit your profile. People do a bunch of things. Let's see. I follow some like people. Let's see. Put my friend on blast, see if he has anything. Yeah, but you can have like your LinkedIn, where you're working. I follow this guy. So he's like big. Tech with Tim is great. If you don't know who it is, he's on YouTube, really with Python. He does a lot with Python, machine learning. He's really cool. Used to work for Microsoft, but he contributes a lot. But you can see, this is kind of all of his things, all of his repositories. You can make it look, when you're working on something, you can pin it up here. You can follow, have your email address. So you can kind of keep it as like people are working with this or want to work with me, or, just kind of another way to get your name out there. If somebody, if you create a cool thing and then somebody finds it and then they go, oh, this is cool. Oh, I want to follow you. Like I think I randomly have like 22 followers or something, but I have no idea why. Right. But people follow me. And so it's like you build up a mass and you go, okay, great. Like, bless you, Jasmine.
Sorry.
You're fine. You you can then have a following, and then whatever that means. But when a recruiter sees that, they go, oh, they have 21,000. Great. For might be an indication. Go ahead, Hop Tommy.
So I have these 2 questions. One is I used to have another GitHub repo with number of repository. And then after some time, I think beginning of Coding Dojo, I create another repo. So I'm trying to merge these 2 repo. I'm afraid if that reset my history, like the activity GitHub. That's one question. Then the other one is like, do people see your activity on repo? Like if you click on the activities, what code they push, if that was public or private?
Yeah, so I think from the activity perspective, it doesn't matter if it's public or private, because GitHub is the one just saying how much are you pushing. For yours, great question. I think I merged mine together because I had 2. My middle name's Cody. That's what I've done my entire life. That's what people have called me. And then professionally, I go by Will in the last, 5 years. But so I had 2. I can't remember if it merged them or not. I would say you could try to merge it, and I don't know that I would look into maybe just Googling, if I merge these 2 together, is it gonna bring all repositories?
You remember when you merged it? Like, can you like zoom out like 21?
I don't remember what year, if I'm honest. It was, if it was 2020 or 21 or something of the nature. So
you click right there like 2020 and then see that activity with there on that reset.
it wouldn't tell the activity of the merging. Yeah. So yeah, it wouldn't show that. Because it says I didn't even code during this time, but obviously I did. So yeah, I wouldn't say the merging. So I'm not sure exactly what the issue is.
Okay,
But
so
yeah.
If you click on one of the Gits, like on July or October, does it tell us exactly like what you contribute? Or
Yeah,
the-
so you don't click, yeah, but it just goes through your contributions. And so
Does-
again, if that's private or if it's public, it still sees how many contributions you had.
Okay, that's for recruiter job hunting.
Yeah, yeah. So recruiters will look at this.
All right, thank you.
Yeah. Colin, go ahead.
Can you go back to your terminal?
Uh-huh.
I just want to see up a little bit. So right there, yeah. So when you did that's good. When you did all right, so we initialize, then we add,
You
and
get
then when
you get add, and then this is just a visualization tool to see the things that we added. You don't have to do get status.
right,
And then once you're done, you commit it.
okay. And did you type go up a little bit one more time? Just like 2 lines. Yeah, so you have to type get status on branch main, or you just do get
Nope,
status.
it's just get status, and then this whole portion came.
Okay.
Just get status.
Status of whatever you were just
Mhm.
working on, whatever
Mhm.
whatever directory you were just in,
Mm-hmm.
or that you just added.
Yeah.
Okay. All right. Thanks.
Yeah, of course. Okay, so we need to now connect these together in the next 4 minutes, which is okay. It's not too hard. You might, and this is in the GitHub section in Web Fundamentals, and I think the video that we had, you might need to set up your terminal to like set up your global variables, because each commit you have an email address and who's committing it. And again, this is so that way when we're taking a snapshot saying, well, who's doing it? And this is really big for like, obviously not for your own, because you know that you're doing it, but when you're dealing with a group, if all of a sudden somebody makes a commit and it breaks your entire thing, you're down, you go, who the heck did that? And if nobody wants to fess up to it, there's like a signature, right? For each one, you're kind of signing your name. So you might have to configure the global variables. But once you get it all done and you have your GitHub, right? We've already committed, right? My repository already lives on my code. All I do is I go to this new button right here. And this says create a new repository, right? Now I want to create a repository on the GitHub side. I've already done it on my machine with Git, but now I want to do it on the GitHub side. So I can do, if I have a template, that's fine. I don't have one. I am part of a couple different organizations. And so I have to choose an owner. You probably won't have to do that because it's just kind of depending on which company. And then here is a repository name. Now it can be anything you want. So I'm going to just call this OG PNA. If I put a space, it's going to automatically put a dash. So you could see it's OG dash PNA. So just know that you could just put OG PNA there if you wanted to. Either one's great. And this is going to check to make sure you don't already have something that has that. Cool. Now a description, it's a great tool, especially for your portfolio projects. You want to describe what you're doing. You can also create what we call a README. A README is a better file for that. We'll look at one at another time. I can show you. You can learn more. Let me copy this. And I'll put this in chat. A README just really explains what is going on here, right? What is this project about? What are you trying to do? What was the point of it? How to use it if you need. So there's lots of great stuff with that. Licenses, again, this is if you're creating, a tool that maybe you use different things or people want to use, you want to allow people to clone and take your stuff, but you're like, hey, there's a license you have to follow in case, your code ends up on a nefarious website or something like that. But you can kind of leave all that empty, and then you decide if you want it public or private, right? Cool. So I'm just going to add in OG PNA, I add public, and I press create repository. So cool. Now my repository is created in Git on my machine, and my repository is created in GitHub, right? They don't know about one another yet, right? So I have to now connect the two repositories. What's nice about GitHub is it tells you exactly how to do it, right? If you didn't do it this is a new repository on the command line, meaning that you haven't already done the steps that we did where we initialized, we added, we committed. You could follow these here. And it has a couple different ones. Really, that's because it wants you to add a README just to say, what is this about? You don't have to do that. Or push in existing repository from the command line. We know that we've got an existing repository. That's what we just did, right? That's our entire terminal. Here's our existing repository. So we go to the repository that has, or to the folder that has the repository. And what's nice is I can actually just copy this and paste it. Now, if you decide to type it out, just be cautious because this is what is connecting. Hey, I want you to connect this remote repository on GitHub to, and on this file to this repository here, right? I want to create this connection. So I like to copy and paste. If not, just be very cautious with you typing it out. Make sure you don't miss the S or the wrong slash or something like that, right? Again, copy and pasting is a better thing. If you don't get an error, that's a good thing. Then we go get branch capital M main. So this is saying, hey, I want to establish that my main branch is main, that is standard. Always call it main. You don't call it anything else. So you could say get branch dash M main. And I will, even though I've done this a million times, will go through and make sure. Cool. No issue. And the last thing I'm going to say is get push dash U origin main. So I say get push dash U origin main. And now this is finally, and remember in the same way that when we added things, that was great. And we actually had to commit it. This get push dash U origin main is us committing and saying, now take the code here or the files or whatever we want to have. And I want you to push it onto the online repository. Cool. So everything worked great. Writing objects 100%. And if I refresh this page, you will now see my code with my message that I made. And now they are in sync, right? I can add a README if I want. They love READMEs, but they are now in sync, right? And I can click on it. I can go to my different lectures. I can go to our office hour. Or maybe lecture 3, office hour, and we have all of our code here, right? We have all that stuff. Now, the last thing I want to do is I want to make a new folder just to show you what happens when we have this repository. How do we add this in, what the steps are? Now, we can show this on another time, but mkdir is how you create a new folder, and then we cd into it. There is a thing that we can do that you can create kind of shortcuts in your computer because I'm tired of typing the same thing all the time. And so I created a shortcut, it's just a function that if I say mkcd, I do mkdir, whatever folder I want, and then it automatically CDs it in for me. So it's just like a faster way to do it. So I can say mkcd week 3. And that's going to make a new directory called week 3 and CD into it. Cool. Give me a second. Tell me. I just want to finish this because we're already past time. Cool. So I've already done that. What I wanted to show is I have now added something new, right? The repository that's on the cloud does not match the repository we currently have. So all I have to do, and this is what's awesome about it, is instead of, I don't have to initialize again. You only have to initialize one time. I say git add space dot, which is just adding everything. If I say git status, you'll see that it's just adding. Oh, sorry, I've got to have a folder. When you have an empty folder, it doesn't actually save that. So let me,
I think that it takes you to that directory, so it doesn't see on the Git repo.
yeah, an empty folder, it doesn't first space in time. Cool. So now, if I were to say git add, I've added a file in there. Cool. Now we see that I've got a new file in my folder of week 3. All I have to do is say git add. So anytime I add something new, I say git add. Again, I could either say that folder or I could say space dot. This is a lot easier right now. And then I say git commit -m added week 3. Cool. I've committed it. And the last thing I say is git push. All I have to say is git push. The git push -u origin main allows us just to say git push. And now git push is it pushes it to my remote repository. So it's those 3 things you have to do. Once you've changed it, you git add, you make a commit, which you always have to do, and then you git push. And that's it. And so now if I were to refresh this, now you see that I've got a week 3 here. And if I were to go back to OGPNA, we have week 3, but now you can see that I have a new message here. Added week 3 versus added PNA, right? And these are my new commits. This is my new commit here. Does that make sense? Cool. I'm gonna stop the recording there.